Hi students, welcome once again back to the channel Math Made Easy with KDY. We are still on the lessons with respect to division between two polynomial functions. In today's lesson, we are going to look at how to divide a polynomial function with a linear divisor. In our previous lesson, we learned using how to divide two polynomial functions using the long division approach. We have a special case over here whereby our polynomial function has a linear divisor. We are going to learn how to use other methods apart from the long division method. But in our situation for today, we are only interested in the remainder when the division is made. So for this, we can use the long division approach, or we can also use another method known as the remainder theorem. Stay glued to your seat and then let's learn together. Let's try using the long division approach and let's see the remainder when the dividend is divided by the divisor. So using the long division method, we introduce our long division sign and we have our dividend as x cubed minus 5x squared plus 6x minus 4. Then our linear divisor is x minus 2. There's something I should have checked before we going ahead writing our division. As I always say, when you want to use the long division method, you must see to it that the polynomial function is written in its standard form. Analyzing the polynomial function, the highest power is 3, and if you analyze it carefully, you realize that it has been reduced until the last power of 0. The linear divisor also has its highest power as 1, and the second term is having a power of 0 for the variable under discussion. Therefore, x will go into s cubed how many times? It will go into s squared times. S squared multiplying x will give us s cubed. S squared multiplies -2 will give us negative 2x squared. At this stage, we subtract. We end up getting 0 for the first term, s cubed minus s cubed, that is 0. Negative 5s squared minus negative 2s squared will give us negative 3x squared. We push down the remaining terms for the polynomial function, which is plus 6x and minus 4. X will go into negative 3x squared, negative 3x times. Negative 3x times x will give us negative 3x squared. Negative 3x multiplying negative 2 will give us negative positive 6x. At this moment, we subtract between the two functions, and that will give us 0 for the first term because negative 3x squared minus negative 3x squared will give us 0. And then 6x minus 6x will also give us 0. So we are left with negative 4. Since s cannot go into negative 4, then it means that our remainder is going to be negative 4. Which means that the polynomial function x cubed minus 5x squared plus 6x minus 4, when it is divisible by x minus 2, there is a quotient of x squared minus 3x, and there is a remainder of negative 4 divided by the divisor, which is x minus 2. But the question was interested in the remainder, so we have the remainder as negative 4. Now, as I said early on, we have another method we could have also used to obtain the remainder -4. And that method is the remainder theorem. Remainder theorem method. Now, with the remainder theorem method, we only apply the remainder theorem method when you have the divisor as a linear expression. When you have the divisor being a linear expression. So take note of it. When you have the divisor as a linear expression, then you can use the remainder theorem to find the remainder between the division of two polynomial functions. Therefore, how does the remainder theorem work? When you have a linear divisor, say per our question x minus 2, you must equate it to 0 and solve for the value of x. So x will be equal to +2. When you find f of +2 for our dividend, then it will automatically give us the remainder for the question. Therefore, finding f of 2 for the function, it will be 2 all cubed minus 5 times 2 all squared plus 6 times 2, then minus 4. Simplifying, we are going to obtain 8 minus 5 times 4, which is 20, then plus 6 times 2, giving us 12, then minus 4. When you simplify the operation, 8 minus 20 will give us -12. -12 plus 12 will give us 0, and it will be left with -4. It will be left with -4. So it tells you that automatically the remainder is -4. The remainder is -4. So please take note of this method. It's very easy and short, for which you can use it to determine the remainder of the division between a polynomial function and a linear divisor. Please take note again, you can only use the remainder theorem when you have a linear divisor. And how do you do that? Equate the linear divisor to 0 and solve for the value of x within that linear divisor. Now you substitute that value of x into the polynomial function, and automatically you will get the remainder for the division between the polynomial function and the linear divisor. We have more work examples to do, so I would like you to pause and go over the video you just watched. Now to the next example, we have f of x giving us 4x cubed plus 3x squared plus x plus 2 being divided by x minus 1. In this situation, we still have a complete or a standard polynomial function being divided by a linear divisor. Now, I showed you how to divide two polynomial functions using the long division method, and I have also shown you how to use the remainder theorem to work out for the remainder. We're still interested in only the remainder. So without wasting my time, I'm going to still use the two methods for you to understand both methods. So using the long division method first, we have x minus 1 as our divisor, and the dividend is 4x cubed plus 3x squared plus x plus 2. Now x goes into 4x cubed, that is 4x squared times 4x squared will multiply x, we have 4x cubed, and 4x squared multiplies -1, we have -4x x squared. Now we subtract between the two functions and we'll end up getting 4x cubed minus 4x cubed, which is 0, and 3x squared minus negative 4x squared, giving us 7x squared. We push down the remaining part of the polynomial function, which is x plus 2. Now x will go into 7x squared, that is 7x times, so plus 7x. 7x multiplies x, we have 7x squared. 7x multiplies negative 1, giving us negative 7x. We subtract between the two functions. We have 0 for 7x squared minus 7x squared. And then x minus negative 7x will give us 8x. Then we push down the remaining part, which is plus 2. X goes into 8x, which is plus 8 times. 8 multiplying the divisor here gives us 8x minus 8. Now when we subtract, we end up getting 0 for 8x minus 8x. And 2 minus negative 8 gives us positive 10. So it tells us that the remainder is positive 10. Using the long division method, we've had the remainder as positive 10. So let's use the remainder theorem. With the remainder theorem, we must consider the linear divisor, which is x minus 1. Equate it to 0 and solve for x. X will be equal to 1. So when we find f of 1, we must obtain the remainder. Therefore, finding f of 1, our remainder will be equal to 4 multiplying 1 all cubed plus 3 multiplying 1 squared plus 1 and then plus 2. So that is going to give us 4 plus 3 plus 1 and plus 2. When we add everything, that gives us an answer of 10. That tells us that the remainder is 10. So I believe the remainder theorem is very useful whenever we are finding the remainder between the division of a polynomial function and a linear function. We have more time, so I believe we can take one last example. But before that, kindly pause and then go through the division between these two polynomial functions, whether using the long division method or the remainder theorem. Now, taking our last question, we're looking at the division between the polynomial function 2x power 4 minus x cubed plus 3x squared minus 1 divided by x plus 1. In this question, as I always say, before you can use a long division approach, you must see to it that the polynomial function is written in its standard form. By looking at our polynomial function, it's missing the x term. So we have to rewrite it as f of x equal to 2x power 4 minus x cubed plus 3x squared plus 0x then minus 1. And our divisor is still going to be the x plus 1 because it's already in the standard form. So using the long division approach, we'll have it as 2x power 4 minus x cubed plus 3x squared plus 0x minus 1. Then we have our divisor as x plus 1. Now, in going forward, x will go into 2x squared, that is 2x cubed times. 2x cubed multiplies 2x squared, that gives us 2x power 4. 2x cubed multiplies positive 1, gives us positive 2x cubed. Now we subtract between the two functions, that will give us 0 for 2x power 4 minus 2x power 4. And then negative x cubed minus 2x cubed, that will give us negative 3x cubed. Then we push down the plus 3x squared plus the 0x minus 1. Continuing with the division, x will go into negative 3x squared, that is negative 3x squared times. That is, x goes into negative 3x cubed, negative 3x squared times. Negative 3x squared multiplies x, that gives us negative 3x cubed. Negative 3x squared multiplies 1 gives us negative 3x squared. Now subtracting, we'll have it as 0 between negative 3x cubed minus negative 3x cubed. And 3x squared minus negative 3x squared will give us positive 6x squared. We push down the plus 0x, then minus 1. X goes into 6x squared, that will be plus 6x times. 6x multiplying x gives us 6x squared. 6x multiplying 1 will give us plus 6x. Subtracting between the two functions, we'll be left with 0x squared, and then we'll be having negative 6x. Then finally minus 1. X will go into negative 6x, that is minus 6 times. Minus 6 times x will give us minus 6x. Minus 6 times negative positive 1 will give us negative 6. When we subtract, we'll end up getting 0 for negative 6x minus negative 6x. And then we'll end up getting 5 for negative 1 minus negative 6. Therefore, our remainder is actually 5. Now, using the remainder theorem, we consider the divisor, which is x plus 1, equate it to 0, and that gives us x equal to negative 1. So finding f of negative 1 for the function, we should get our remainder. Therefore, the remainder will be equal to 2 multiplying negative 1 to the power 4 minus into bracket negative 1 cubed plus 3 multiplying negative 1 all squared, then minus 1. And that will lead us to 2 plus 1, because negative 1 all cubed will give us negative 1. Multiplying 1 will give us positive 1. Multiplying negative sign giving us positive 1. Then over here we have plus 3, then minus 1. When you put the 2, 1, 3, negative 1 together, you end up getting 5. So it tells you that the remainder is positive 5, as we can see it using the long division method. So I believe the remainder theorem has a very great impact in division of polynomial function and getting the remainder directly without going through a stress of using the long division method. Thank you so much for joining the lesson. I'm very glad being a facilitator to help you understand mathematics. I'll please request that you subscribe to my channel and then support the course. God bless you.